there has got to be a faster way to do this than slowly clicking everyone's faces. But maybe people like that. It's like this slow reveal. Like, who's it going to be? All right, well, hey, everyone. My name is Fraser Cain. I'm the publisher of Universe Today, and this is your weekly Space Hangout for Friday, March 7th, 2014. We've got big news today. We've got close paths of asteroids, asteroids falling apart, gravitational lensing, the NASA budget, and possible evidence for dark matter, quasars. It's going to be cool. And we've got a sneak preview, well, not exactly a sneak preview, of the new Cosmos series. Alan's seen some of it, and he'll be able to talk about it. So, and speaking of Alan, we're joined by Alan Boyle from NBC.
Hey,
Alan?
yeah, I finally figured out how to hook up this Google thing.
And I just want to note your lighting is just, it's perfect.
The sun is shining in Seattle, so that's what makes it so nice.
That's awesome. Well, it's great to have you back. We got Brian Coberline. Hey, Brian.
Hi. How are you?
Good. We got Casey Dreyer from the Planetary Society. Casey.
Hey, Fraser. Happy to be here.
You are not.
Yes, I am.
Okay, good.
Happy news.
Okay, good. All
It's a
right.
mix.
You're happy to be here. You just don't have happy news. All right.
I can
We got
still
Dave
be bold.
Dickinson. Hey, David.
Hey, another wacky week.
It has been a wacky week. Got Major Jason Major.
Hey, Fraser. I'm trying to get better lighting because I'm jealous of Alan. So.
We all are now.
And we got Dr.
on
Matthew
down.
Francis, newly returned from Science Online, and I hope you can let us know how that went as well.
If we've got time, yeah, I think NASA budget is probably going to eat up a lot of our brain power this afternoon, but we'll see.
I won't let it take that too.
I've got science to talk about, too. I've got to talk about science.
I know. It's taken so much, I'm not going to let it. So I apologize. I've got a bit of a cough going on. I will try to mute as I hack and cough. Now, before we get on to the actual show, I just want to do a little bit of housekeeping here. One is that you can always interact with us. We love to hear your comments and questions. So the best way to do that is to use the Q&A app, which I have enabled for this Hangout. You should see that no matter where you're watching this. You should be able to see that Fraser is interacting with the audience, and you can come in and have a conversation with us, ask us some questions, and I will try to insert them into the show. The second thing is the Weekly Space Hangout is going to iTunes. So we know that a lot of people have wanted to get a podcast version, video and audio of the show, and Susie Murph, who's our producer for Universe Today, is going to be helping to bring that over to iTunes. So hopefully in the next couple of days, you'll be able to subscribe on iTunes and just whatever podcatching software you like, and you will have it downloaded onto your portable device, just like Astronomy Cast and other shows like that. So, not that we wouldn't love to have you join us live, but I know that a lot of people really like to get the stuff on their portable device, like me. So, so we'll get. That's what we're gonna do. So first, let's start, and I gotta know, Alan.
Yeah.
For some reason, the good folks at Cosmos chose you.
Well, no, Neil and me.
I know,
we're
you
just
guys
like
are
that.
tight.
Yeah,
Tight.
We're the yin and yang of the Pluto controversy. They just sent out previews of the first episode of Cosmos, the show that made such a splash in 1980 when Carl Sagan brought it to primetime television, and it's coming back to primetime television starting on Sunday with Neil deGrasse Tyson as the host. And so
Now, I would show a preview of the show, but then this show would be taken offline on YouTube. So I'm not going to do it, and I will.
But you would get billions and billions of hits. So,
billions and
there
billions
you
of
go.
copyright takedowns is what I would get. So let's just assume it's going to be a show. It's got pretty pictures. Neil deGrasse Tyson talking.
Yeah, well, the pretty pictures are not an insignificant thing. That special effects have come a long way since 1980, and so you'll see that reflected in the show. That's one of the big differences. Another difference, there are some of the aspects of the science that have changed. The explosion in extrasolar planets. Actually, the explosion on the rim of our own solar system. All the objects that have been found in the same vicinity as Pluto. And speaking of Pluto, you might know I wrote a book called The Case for Pluto that tries to lead the defense for that poor dwarf planet. There's a tangential reference or two to Pluto, but even if you're a Plutophile and you think that Neil is on the wrong side of the issue, you shouldn't get too upset. It's just a tangential thing, so don't worry about that. This first episode follows the game plan, really, that Carl had for his first episode, laying out the space and time parameters for the whole cosmos. Back in 1980, it was thought that the universe was maybe 15 billion years old, but people really didn't know precisely. Now we know a little bit more precisely. It's 13.8 billion years or so. And so that's reflected in the cosmic calendar. This device, it's a cool graphic that shrinks the entire history of the universe down to 1 year and all of recorded history down to 14 seconds on the last day of the year. And so that is something that was carried over from the first series. Another thing that's been carried over is the ship of the imagination. This is something where you saw Carl sitting in the driver's seat, and that would take you to all the far-flung frontiers of the cosmos. And there's an upgraded, pimped-out ship of the imagination that Neil deGrasse Tyson is using for his show. So, but the spirit is the same. Like I say, there are some extra twists that have come up since 1980, and we'll be getting into more of that as the 13-episode series progresses on Fox and the National Geographic Channel. About the multiverse, about discoveries in evolutionary biology, and another feature is that they have animated sequences that pay tribute and tell the story of people throughout history who have championed the ideals of scientific discovery. The first one is Giordano Bruno, this friar who, back in the 16th century said that all those stars in the sky must have planets around them, and there may be people like us on these planets. And he was burned at the stake because of his views on that and other subjects. And but it turned out that new planet thing wasn't such a crazy idea after all, and so that's explained in the context of what the frontiers of our universe look like. And in the future, they'll have more of these animated sequences that kind of bring a new dimension to the show, put scientific discovery in a historical perspective. So that's the sum of what I took away from the show. I did write about it in a preview on NBCnews.com, and so if people want to get more details and want to hear what Ann Druyan, Carl Sagan's widow, who was such a powerful force in the old and the new cosmos, if you want to hear what Ann has to say about it, you can see that story as well.
Yeah, we'll put a link to your article in all of the various show notes that we do, because it was just it was a terrific article, and that's what got my attention. And I nagged you, and then you said, "Oh, I'll jump in and tell you what I thought." So, did you enjoy it?
I did. Yeah, it's. I guess some people have talked about how Neil comes off in it, and Neil deGrasse Tyson is a little bit better if he's more extemporaneous, if he starts to mix it up a little bit. This is more of a scripted sort of thing. It's very much like the Carl Sagan tone, and I think Neil is probably going to take a while to get comfortable with that tone. He does go back to his own encounter with Carl Sagan when Neil was a 17-year-old student from the Bronx and went up to visit Carl, and it's a nice way to kind of bring the whole thing full circle, that the torch has been passed to a new generation and a new show. So I don't know, I wouldn't make too much of the Neil versus Carl. Some people have compared it to Kirk versus Picard, but I would say just kind of enjoy the spectacle of it, because of course the way that the story is presented with all the tools that are available in the 21st century is really what makes this cosmos fresh and new.
How is it on the spectacle front? Because we've seen, and many of us are responsible for digging up the same tired animations of black holes and sweeping views of from Cassini and things like that. So did they go back and throw a lot of money into the computer graphics and the stuff you see on screen?
Yeah, they did. I mean, it's hard for us. We're so inured to how things look with these state-of-the-art animations from NASA, showing Curiosity's landing and how Voyager does its thing, so that it doesn't, in terms of what people have done in space animation today, it doesn't break new ground. But if you go back and look at what it was like for the first Cosmos, you will immediately see how much things have changed in the past 34 years.
Yeah.
Alan, I don't know what you had heard about as far as Cosmos coming out online. I had got a contact with the VP of digital production at Fox, and apparently they are going to trickle it out over the internet for people that consume their media solely on the internet over the next week or so. Is what I had heard.
Right. I've heard that there's an app in the works, and
yeah, like
I'm
on
sure
Amazon, or they're going to be available.
Right.
To not release that on the internet is
would be folly.
crazy.
Yeah, that would be folly. So
yeah,
but David, I think you're right that they're having kind of a staged rollout of this, and so I'm sure that's going to be another headline in the next few days. Is Cosmos on streaming services, or Cosmos on your mobile phone?
Yeah,
that's definitely in the works.
The answer I got back is within the first week or so. They're probably going to start trickling it out.
Now, I don't know about you. I sort of obsessively watch them all for research, of course. Through the wormhole and the universe and things like that. I mean, and Brian Cox's Wonders of the Solar System and things like that. So where would you sort of put it on that? On that hierarchy? Would you say it's the best?
Actually,
space?
That's a really good point. That's a good point, that there are more resources available, and there are more people in this business now than there were when Carl did the first series. And so I think for people like you, Fraser, you're probably not going to find a whole lot new in this, and you might kind of think that it's treading over old ground. But remember, this is something that is aimed at a primetime audience. It's on Fox. It's not on the Discovery Channel or the Science Channel. So I think for the hardcore geeks, it might look like it's a great presentation, but we knew all this stuff already. But I think the audience here is the broader general public, and really arguing the case for science. That's something that came through in the first series, and it comes through in this one as well, is that science has had a kind of a rough time on the cultural battlefield lately, and this definitely takes a position on that battlefield. So that's something that makes this series perhaps different from something like Through the Wormhole,
which has gotten pretty weird. So in the later seasons. Okay, cool. Well, I mean, I'm super jealous you got a chance to talk with the people behind the show, and I'm glad you got a chance to see it in advance. And I think we'll probably provide people with a quick synopsis every week of what we thought.
Oh,
Next
yeah,
week,
I think Monday morning.
All brains, all of our critical mind power will come down hard.
Get around the water cooler on Monday.
The virtual.
It'll be cool for us to be Monday morning science quarterbacks, and to maybe we can kind of hash through every episode as it comes out over the next
science communication quarterbacks, right?
It's going to be going. It's going to be going head to head with the virtual Star Party every Sunday night. So.
No!
We'll be after it. We'll be afterwards, I think.
I wonder if they'll put a link to us at the end of the show then.
I'll work on that.
All right. They could totally show up in the virtual Star Party. Anyone wants to come? No, we're too Bush League. All right, let's get on with the next big story. So thanks, Alan. Now you can stick around if you want and, and contribute, or you can head out and write more stories. So either way. Now, Casey, we're gonna move to Casey because I know you've got a book out pretty quick. So let's get on with the update. And so last week you gave us this optimistic preview of the 2015 NASA budget. So how did it all go? How did it all turn out? I was skeptical.
Well, it was mixed. It's a big budget. NASA does a lot of things, and there's going to be good and bad. And of course, there was good and bad. Nothing too surprising except for one. Well, I would say two things. So let's start at the kind of the big picture. What does this mean when we're talking about the NASA budget right now? So what happened was the Obama administration, the president, makes this thing called the budget request for the next year up ahead. So it's basically setting kind of the initial conditions of the budget discussion for the next few months. It gives it to Congress. Congress takes that request, does whatever they want to it, and then appropriates the money. But it's this conceptual anchor, so it's very important. And then as soon as it's published, it does represent essentially official NASA policy as described by the White House. So it's an important thing, but it's far from being the final word in the budget. It's kind of the first volley of this discussion. So just keep that in mind for everything we're talking about right now, is that this is the proposal. This is not set in stone. So with that said, the big picture NASA top-line budget, the White House proposes to cut by about $200 million. Most people, this was a surprise to me, honestly, and this was a surprise to most people. For the past few years, NASA's been flat at about $17.7 billion. The Obama administration now is proposing 17.46, which is less than their levels that they had been proposing in the previous years, and also less than Congress has been giving NASA, particularly last year. So that's not good, obviously. You know, people were pretty worried as it was that NASA wouldn't be able to pursue all of the things that it has to by law with a flat budget at $17.7 billion. Now it has $200 million less. Everything gets squeezed a little bit more. So that's the top level thing. And kind of the big cut, that this is the big shocker, I guess, for the budget, was that one of the big fallouts was this, is that the Sophia Infrared Observatory, this modified Boeing 747 that flies around above the water level in the atmosphere and observes distant stuff in infrared, gone. They basically said, we can't afford this mission anymore. It had the second highest operating cost of any NASA science mission, second to the Hubble. So it was kind of a big, tempting target for NASA, and they said, we can't afford to run this anymore, so they are planning to ground it in 2015, not destroy it, but just put it in storage, and unless German partners, which participated in creating Sophia, step in to pay the difference. So this is that was the big shocker for the mission for NASA. A few other kind of notable things: they proposed a little bit more money than they proposed last year for planetary science, which of course is near and dear to our hearts here at the Planetary Society. That is still below what Congress has been giving it every year. So it's effectively another cut. So they're cutting planetary science again, just not as much. So I kind of take that as a progress. It's a step. Within that, the kind of the good news part of that is that they put aside a little bit of money, $15 million, to study a mission to Europa. Now, this doesn't sound like a big deal because NASA has been getting $80 million for the last 2 years by Congress to study a mission to Europa. This is the Clipper concept that flies by Europa something like 50 times and maps it out, has radar, penetrates the ice, and so forth. Could fly through the plumes. But NASA has never accepted never wanted the money. Congress has just been giving it to them. Congress wants a mission to Europa. I would say the people around the world want a mission to Europa. NASA administration, strangely enough, has not really embraced this mission concept. So what's happening is now NASA has kind of acknowledged, like, okay, well, Europa might be an interesting target to explore. There may be something to what the entire scientific community thinks about this. And they put in a little bit of money for future mission studies. Now, the big caveat of this is that they're saying this mission probably won't launch until the mid-2020s, and let's say less than $1 billion, which is less than half of the reduced cost mission that they had been already thinking about. So $1 billion, again, sounds like a lot of money to you and me, but for a mission that has to survive in this really harsh radiation environment of Europa and the Jovian radiation environment, that's going to be tough to squeeze a mission under that budget line. So, again, mixed. I'm happy that NASA is now acknowledging that Europa seems like a good destination. I want a mission that solves these big science questions about Europa, because this is essentially a once-in-a-generation mission. And until we start cutting metal, 5 years of mission studies, doesn't really get us anywhere. That could be easily canceled in the future. So I want something a little more bigger commitment from NASA, but I'm happy that they're acknowledging it. Other big ticket items, the SLS and Orion, fully funded, about the levels that Congress wants, so those are moving along. The James Webb Space Telescope, fully funded along exactly what it's been getting. That has strong support also from Congress. That's moving along. Beyond that, NASA just kind of constricts a little bit. They cut education by about 20%. They tend to do this every year. Congress almost always puts more money back in education, so I'm concerned but not particularly worried about its education outreach budget. Those are the big picture things. So the things to take away. NASA's down a couple $100 million, tightens everything, we lose Sophia, planetary gets a little better, science overall, everything is cut, which is just generally, I think, not good as a thinking human being. So that's the big picture NASA budget proposal.
So I didn't hear a lot of good news in there. I don't know if anyone else heard. You said good news and bad news. I really just heard bad news.
The good news is Europa. I mean,
the good news is that NASA is gonna maybe consider the $80 million per year that's piling up in some locker in some hangar somewhere, and they're gonna start spending that money. That's the good news.
Think of it as a conception. I think of it as we've gotten our foot in the door. NASA, NASA last budget, 2014's NASA budget proposal, it was this really weird because they had multiple places in the budget that says, by the way, we're not going to Europa. We cannot do this mission, just so you guys know. And so it's kind of like this weirdly antagonistic attitude about it. This year, the fact that it's in the budget line somewhere, even though it's not the big mission, that's a huge conceptual step. So again, we've wedged our foot in the door, now it's up to us. And this is where I turn into my advocate mode. It's up to us to crack open that door and get a real solid mission to Europa, not in the mid-2020s, but early 2020s. That we can do, and that's what we need people to write and call their representatives, write the president, write NASA, and that's all at planetary.org/SOS. So we're starting to get this stuff up.
Well, let me see if I can take a crack at this. Let me see here. So NASA, Europa is one of the most interesting and exciting places in the solar system. There is evidence that there's liquid water underneath the ice surface. There are plumes of water ice spewing onto the surface that we could examine for evidence of life outside the Earth. Let's go. All right. There. We'll see if that works.
Yep, that's all you need. So again, this is starting off the big process. Congress starts to meet in the next few months to look at and respond to these budgets. So this is where writing now is going to be very important. The other piece of news that I should say is that Cassini and Curiosity seem to be safe next year. So they will both continue to operate. They're not going to crash Cassini early. That was one of the worries. However, Opportunity is now threatened. There is no guaranteed funding to keep operating Opportunity on the surface of Mars. So that's something we're going to have to look at really closely.
I have already committed the resources of Canada to take over these missions if it's necessary. So, like, literally, as soon as you guys are done with those spacecraft, we're all over it.
All right, I'll let them know.
All right.
I think it's kind of sad.
You know what would be nice? You know what would be nice? It would be nice if we could have exploration and science and all of that stuff that we all love, not at the expense of other exploration and science.
I have already solved this, Jason. Haven't I already solved this?
Canada's great. We love Canada.
They are two separate things. Human space exploration and science. They're not the same thing. They look the same because they use rockets, but they're not. They're different. And as soon as you put them in the same bucket and make them fight, it's friend against friend. It's the worst. So no. They need to have two separate, an entire new agency, perhaps like the National, Science Foundation or something like that. That's what I was thinking.
Wait,
have them handle, let them handle the planetary exploration, and they have their own budget, and then you can have the National Aeronautical Space something or other, and have them handle exploration. Keep completely separate, and then we don't even have
the Space Marines. Send in the Space Marines.
As long as the travelers, as long as the explorers aren't actually thinking or doing any science.
No, they cannot. They're not. No, literally, their job is not die in space. That is their job. Their job is go to asteroids, come back, go to the moon, come back, go to Europa.
Don't think about anything.
Fight the bugs.
Don't do any science while you're out there. It's just extra weight. Just show us how to live.
I did want to mention on that theme of human spaceflight and commercial crew, it sounds like things are a little more promising on the commercial crew angle. I think that it was something like $850 million that was requested for commercial crew, and there was an option for additional funds, if I'm hearing it right. And
That's always been the big problem, though. The administration is actually very behind commercial crew. It's Congress that keeps taking money away from. They've underfunded commercial crew consistently since the program began. The big question is, and the extra $200 million comes in this amorphous, what I call the wish list, the Opportunity Growth and Security Initiative, which is an extra $56 billion of spending that the White House has proposed that it could pay for by closing tax loophole taxes on high earners, which basically in this political environment guarantee it will never happen. And so whether or not they can pick and choose from this wish list, but the money is not going to just show up. I don't think Congress is going to close any loopholes anytime soon.
Sorry, for anyone who doesn't know, what was commercial crew?
Commercial crew... Sorry, Alan, would you like to explain?
Oh, no. Commercial Crew is the program to develop replacements for the shuttle fleet, like the SpaceX Dragon, the Boeing CRS-100. These are spaceships that would be capable of bringing U.S. crew back and forth to and from the space station for the first time since the shuttle fleet was retired in 2011. And as Casey says, it's not been popular with Congress because Congress feels that they should be giving a lot of money to develop big heavy lift rockets like the SLS and not so much money to these commercial, mammals who are underneath the dinosaur feet. But that may be changing, and one of the reasons for that is Ukraine. That some Republican legislators are now saying, why is it that we're giving Russia who are becoming our even bigger rivals, why are we giving them $70 million a seat to send people to and from the space station? And so there are some rumblings that the whole Ukraine crisis may make Congress feel a little bit better about developing a U.S. commercial crew carrying capability again.
All right, well, let's move on because we could literally talk about this all day. Casey, I know you got to go, so you are free to run whenever you need to leave.
Thanks can I plug one thing, Fraser?
You want to plug yeah, you can plug a thing.
Okay, so we actually on Planetary Radio on the Planetary Society, we ended up talking 35 minutes on a special episode on a podcast. So we can hear me and Matt Kaplan talk about these kind of same ideas, including commercial crew, how the Ukraine situation affects that. That's at planetary.org/radio. We have all sorts of things on planetary.org/SOS. All the written details will be following this more next week, too. So make sure to follow us there.
Yeah, definitely sign up to Planetary Radio. It's a fantastic podcast.
All right, thanks, guys. Sorry I got to run. Have a great rest of the show.
Go fight the fight. All right, boy, so we've got a bunch of other stories. We want to get zipping through them. So first, Brian Coberland, and I saw this. Let's talk about possible evidence for dark matter WIMPs.
Okay, this is interesting, but it should be emphasized that it's tentative.
Okay.
There is a preprint.
Okay, I'm glad you're saying that.
You're glad I'm saying that?
Yeah, so I don't have to.
Okay. Yeah, it's very tentative. It's a preprint for one, and even when it gets published, it's still pretty tentative. Basically, there was a team that looked at Fermi gamma ray data, focused at the center of our galaxy. And there's a lot of gamma rays coming out of the center of our galaxy. And what they did was they looked at this data and subtracted out all the expected gamma rays from various sources. And so things like millisecond pulsars and other things that produce gamma rays. And what they found was what looks like an excess signal of gamma rays near the center region of our galaxy that looks like it could be dark matter colliding with itself near that central region producing gamma rays. And if you do the modeling, the strongest model is dark matter WIMPs, weakly interacting massive particles, that are about 35 GeV, giga electron volts. And that's like their best signal. They think they've eliminated any other possible source. And the profile matches pretty well the kind of expected dark matter distribution that you would see there. So it's interesting.
Right. So if I understand this this problem that dark matter, doesn't seem to have any size, and so when the dark matter particles pass each other, they seem to just go right past each other, and they're never colliding. But what you're saying is that in fact there might be some evidence that these particles are actually bonking into each other, and when that
Right.
happens, you're getting a release of gamma radiation.
Right. And so they're having some collisions there.
Right.
It's
I know,
an interesting signal, but it relies on a lot of data analysis, and so.
And Matthew, do you want to be skeptical about this, or did you think he gave enough caveats there?
No, I think there's plenty of. I think those caveats were all the ones I would give, and just for those who aren't up on particle physics terminology, 35 GeV is about roughly 35 times the mass of a proton. So this is like middle range of what the WIMP models predict. So, and I want to throw the question back. I was meaning to look this up, but this week's been kind of insane. How does that compare with LHC findings for WIMPs? Because I know a lot of ranges have been excluded, and also lux.
Yeah, I think one of the things that makes us tentative is that we would very likely see these types of particles. I mean, 35 GeV is not very energetic when you really come down to it in particle physics.
Right.
So the kind of argument would be that there are models of dark matter WIMPs in which they're their own antimatter particles, and so they're colliding this way. So basically the argument would be we're not really seeing them because there's some disconnect between WIMPs and regular matter. So there's something strange there. There would have to be some kind of strangeness there. I don't think the particle physics stuff entirely excludes this, but I think one light curve of gamma rays does not dark matter show. So that's kind of where it is. This is one of those things where we're dancing around the edge here. I think we're going to see a lot more of this of maybe kind of something is interesting there.
Right. It gives the LHC people
we'll
something to look for, very specific experiments to try and replicate using their equipment and try to see the same outburst of radiation at that same level of energy. So
right.
And several of the dark matter
problems is we don't know how it interacts with the matter.
Yeah.
All right, well, let's move on because there's a lot of stuff to get through and not a lot of time to do it. So I'm going to go next to Jason, and you're going to talk about an asteroid that we watched fall apart.
Yeah, I mean, this is space action, getting caught in the act, rather than dark matter that we can't find yet, and budgets that make us cry and things like that. Here's some space stuff that's exciting, and I've got a clip of it here. So
have you got a picture? Okay.
I do. I have a picture. I'm gonna pull up the screen
right.
share. Click the screen share, and nothing happens.
Yes, that problem.
Yeah, for some reason the screen share is not.
That has been known to happen.
Oh, okay. Well, sadly,
allow me to find an image.
I have a link that I will copy and send over to you, Fraser.
Okay. You can also use the I don't know if you can use the Hangout toolbox to do it.
There's a link. Anyway, so. Okay. What's been spotted is an asteroid in the main asteroid belt, literally falling apart. Now, and it's not because it's been hit by anything, except perhaps sunlight. And this is a good-sized asteroid. This is 200,000 tons, and over the past year or so, it's been spotted, and then from October until January, it's been observed by the Hubble Space Telescope, and and Fraser can call this up, that's the series of images that you're going to be seeing. And this space rock is literally just falling into bits and pieces. And it's happening in kind of a slow motion because each of these chunks is really traveling relative to the other chunks only about 1.5 kilometers per second. So, I'm sorry, 1.5 kilometers per hour. So that's about the speed that you would walk. So, these little bits and pieces are walking through the main asteroid belt and just disintegrating, and maybe someday they will become a meteor shower that will, impact Earth's atmosphere and be pretty lights in the sky. But for now, they're a curiosity for the Hubble Space Telescope to take a good look at. And what's interesting here is it's why this asteroid fell apart. Like I said, it wasn't hit by an object. but it was hit by sunlight. It's a demonstration of a hypothesized effect that it's called YORP, which is the shorthand for the Yarkovsky effect. Now there's a whole string of names there that I can't recall, but that's the Y in YORP. The Yarkovsky effect is when sunlight strikes an object in the, like for example, an asteroid. That object gathers some of the radiation, some of the radiative energy from the sunlight, and then reflects some of that energy back out into space. The action of it releasing this energy affects the motion of this object as it's moving. So it can actually cause it to rotate differently, and it can affect this object's rotation. Now, the change in rotation of an object that's already kind of lightly held together by its own gravity, this asteroid was probably just an icy, rocky rubble pile to begin with. Mm-hmm. It may have been hit many times in the past over the course of its life. So if it's radiating energy back out into space that affects its rotation, it's going to experience some shear just by the alteration of its rotation. And that shear is enough to just make it crumble apart. And so that's what we're seeing here, and it's really the first time that this has been directly observed happening. So that's why this is exciting, and that's why this is cool, and absolutely love that animation. Now that came in from Hubble. David Jewett of UCLA was lead on that team, and very cool stuff.
I wonder how they knew to target that asteroid, that it was about to do this, because there's so many objects they could look at, right?
It had been spotted as a fuzzy object in the belt by I can't remember which observatory originally spotted it, but then it was called up as a target for Hubble. So when they first saw it in, I think, September or October, they saw that it was literally crumbling apart. So they kept watching it, and that's the series of images that we have now. Now those images were taken in October, November, December, and January, and that's why they're just kind of like crumbling. Now if it was an impact, pieces would have been everywhere. They would have been traveling at high velocity relative to each other. There would have just been, stuff flying in all different directions. All these bits and pieces are going in basically the same orbit that the asteroid was originally going in.
Mm-hmm. Yeah, I think it was the Catalina Sky Survey and Pan-STARRS that pointed it up. And another thing about this is that Jewett and the other researchers are starting to suspect that this is the way that small asteroids kind of crumble apart, and the debris from those asteroids are what become meteors coming through the atmosphere, and so it's actually kind of feeding the beast, and this is the way they do it, maybe.
Well, that makes a lot more sense, too, considering that the object in the asteroid belt, it's not like, from Empire Strikes Back, where there's just things flying all over the place. The chances of them hitting each other, while not impossible, are a lot less likely than them falling apart through this Yarkovsky effect, which is basically just the asteroid and the sunlight that's hitting it. And, of course, there's constantly sunlight out there. So.
And it's constantly hitting at the speed of light, right? And so I guess there's no limit. So if you run this simulation forward billions or trillions of years in the future, will you end up with all of the asteroids eventually spinning themselves apart, depending on what they're made out of? Brian is shaking his head no.
Well, I would think that the Yarkovsky effect is only going to go so far if the asteroids are large enough. Their own internal gravity will be able to counter that that shear effect.
This would be for largely rubble type asteroids that are loosely packed could do that.
Yeah.
Larger ones that are under their own gravity that are differentiated wouldn't do this way.
All right.
And we do have asteroids that are from impacts like that.
All right, so Dr. Matthew Francis, now you're going to talk about using gravitational lensing to measure a spinning quasar, and I would like to tell you how this impacts my free will.
Oh wait, that's a different story. You're missing two stories up.
I am not. I'm actually joking about the second half.
Okay. The free will one was the week before, and
I know.
I think that's going to be too involved.
Yeah, we didn't want to go anywhere near it. So
no, this is a complete mic drop for observational astronomy. Because the quasars are very, very distant. Most quasars we see are at vast distances away from the Milky Way. And so to be able to measure the rotation of the quasar, even to within the margin of error that they have, which is a fairly large margin of error, but it's still being able to measure this rotation is mind-blowingly awesome. Because, okay, so this is 6.1 billion light years away, so not quite halfway across the universe. I think I said halfway in the headline just because it's shorthand, but that's a huge distance away. But the nice thing is there is an elliptical galaxy between the Milky Way and this quasar, and so the gravitation from this galaxy split the light from the quasar into 4 images, which they then reassembled, stacked onto each other to basically have 4 times the amount of data you'd ordinarily have, which is also a great trick, and used that to be able to measure the speed that gas is swirling around this supermassive black hole. And the supermassive black hole is 200 million times the mass of the sun. So this is, a pretty substantial black hole, especially to have formed that early. So basically we've got a bit of serendipity, but we've also got some serious mad astronomy skills going on here. But what they were able to do is they were able to measure the speed of this black hole's rotation is somewhere between 66% of the maximum amount it can have, and is likely larger. So it's at least 66%, but it's more likely much closer to the maximum it can be.
Yeah,
well, that's important.
But I mean, when you say 66% of its maximum speed, I mean, we're relativistic here. We're talking about, like, what's the maximum speed? Like 80% of the speed of light or something like that?
Well, okay, now that's another story in and of itself, because trying to talk about the speed of a black hole spinning in absolute terms is, that gets more into general relativity than we probably have time. But yeah, I mean,
Just give me a number.
No, sorry, won't.
42.
Shan't.
42.
No, but
Yeah.
suffice to say that if you were in a spaceship riding the conveyor belt of gravity around this black hole, people would be measuring your speed as being a substantial fraction of the speed of light. And that's what matters, right, is the speed that matter is moving on this gravitational conveyor belt. And that's going to be highly relativistic speeds, very close to the speed of light. And of course, that's part of the reason why quasars are so bright, is because gravity is carrying the matter around, it's accelerating, it's emitting light, huge amounts of light. And producing magnetic fields, which also, will spin matter up even faster. So basically, that's what we're seeing. When we see a black hole, what we're seeing is the matter being carried around by the gravity. So we can constrain the speed the black hole must be rotating by the light emission. And in this case, what we're seeing is iron atoms, light reflecting off of these iron atoms, and we're able to measure how fast this disk is swirling around the black hole. And so the cool thing, though, is finding out that a black hole spinning that fast that early in the universe's history means that it had to have been spun up by 2 black holes colliding and merging. That's important data. We're still trying to figure out exactly how the biggest black holes got that huge. And so this is admittedly only one data point. So the theorists are still going to be disappointed in this, unfortunately, not because we'd like to have a lot more of these, and it's going to, again, we're going to have to repeat this kind of ninjery to get more of these, but it is really, really exciting stuff, because now we can say at least one example shows that black holes, the biggest supermassive black holes, must have grown that way by mergers, not by slow growth.
And it's mind-bending that they used a gravitational lens to pick it out. I mean, that's, as you said, that is absolute ninja observational skills to do that.
Let me pull up the image for you real quick, if I can. Maybe it'll let me.
And hopefully, I mean, when the James Webb Space Telescope does show up, we're going to be able to get these kinds of this far out without necessarily having to totally rely on gravitational lenses, because you don't get to make a very good you don't make a good survey of all of the objects that are out there. You only get the ones where you happen to get a galaxy,
Right.
lensing in front of a more distant object.
Okay, so I pulled up the picture. If you can have a look at that, you can see that there's kind of a ring that's known as an Einstein ring, and inside that ring there are 4 bright points of light. Those are the 4 images of the quasar. So we are actually seeing at the center of the image, which is slightly different color, that's the galaxy that's creating the lens. That's an elliptical galaxy, and then the kind of magenta dots within the ring are the quasar. So that's really cool to think about too. We are actually able to see details of this. And gravitational lensing, of course, is inherently cool, and I'm teaching a class on it next month. Advertisement for that. So if you're interested in gravitational lensing, I'm sure I will find room in the class to talk about this very quasar, because why not?
People have asked me about that very same image, and so I will share the information that I said back to them. They wanted to know, is that a real image? Is that an illustration? I said, well, it's kind of a combination of images from 2 different telescopes. The X-ray image is shown in the pink and purple, and that's from Chandra. And then Hubble has the rest of the optical light data, and that's the other stuff that's in there. So a combination of those. It's more real than an illustration would be, but it is a composite of separate data.
That's real enough. That's real for astronomy.
All right, well, we're running out of time, and I gotta get to David, or he's gonna leave, I guess. That's okay. So first, David, now you hate daylight savings time.
Pretty much, especially.
But you're a little quiet, Dave. Could you come closer to your microphone, maybe?
Yeah, can you hear me now?
Yeah.
Hello. Yeah, pretty much. We spend about 67% of our year on daylight savings time now. We shift forward this Sunday, which is, ever since 2007, they rolled daylight savings time back to the second Sunday of the month. Over in Europe, they still shift on the last Sunday of March, so we're going to enter into that weird 3-week time period where we approach Europe by an hour, then they recede away from us an hour again. And it's just a very confusing situation. I found out, as a matter of fact, I didn't know up there in Canada, part of British Columbia doesn't observe daylight savings time. Not where you are, Fraser, but
we sure
there's
do.
An area. You do. Most of Saskatchewan doesn't. It's kind of confusing if you study all these little exceptions out there. And I know from people that program computers, they really kind of despise it too, because anytime you release an app or any kind of program that's reliant on what the local time is, you have to build in all these little exceptions for Afghanistan as a half-hour time zone, Northern Territories in Australia is a half-hour time zone. Florida wants to go to permanent daylight savings time, which would be really weird in that sense that we would actually be out of sync with the East Coast during the winter time. So it's just I would always propose that we just go to universal time and I would like to do away with time zones entirely if I was running the world. So
we should go to Swatch. We should go to Swatch Internet time. Let's take it one step further.
There you go.
And go to Swatch time.
And as far as astronomical time versus chronological time, there is talk about doing away with adding leap seconds in too, kind of a related subject I just found out a few weeks ago. You know how we add in leap seconds to keep terrestrial time in sync with astronomical time? They are doing a vote next year in November. I believe it's the National Institute of Standards and Time, where they may eventually want to do away with that. And I know computer programmers despise that too, that adding in that leap second really wreaks havoc with a lot of programs. So it'd be interesting if that occurs. That means we're actually moving off a natural time source in the astronomical time, in the time that we reckon will slowly move apart, maybe by a minute or two per lifetime, but eventually, after a few millennia, the sun will start rising an hour earlier than it should locally, just because we're not following that time standard anymore. So it's kind of bizarre, the situation we're in.
Madness. Let's get rid of daylight savings time. Let's start there. Let's just kill it.
Yeah.
It's no good. And then we'll work there, and we'll switch to Planck time.
I say just go to universal time and just everybody just one time zone worldwide. But I saw some interesting proposals when I threw it out there. Some people were talking about going to permanent daylight savings time. Oh, and incidentally, and even I say it wrong, it's not daylight savings time, it's daylight saving time. Before somebody corrects me, I know there's no S in there, but my tongue just wants to
Stephen
throw it
Hawking.
Yeah.
Cool. All right. So now, and also, there's going to be a close pass of a asteroid on Wednesday.
There was this past Wednesday.
Oh, there was.
Three
Yeah.
We had three that We had three that passed closer than the moon, and the first one we knew about last weekend was 2014 DX-110 that passed 90% of the distance to the moon. Pretty big. It was about the size of an office building. It was 30 meters in size. This was the biggest one this year so far to pass within the Earth-Moon distance. And there was a little bit of excitement last Sunday night when they had the first initial orbit calculations in. It was on NASA's NEO risk page very briefly. For a 1 in a million chance for an impact in 2043, they ruled it out. That usually happens once they start looking at and getting better and better refinements on these orbits. You see the risk go down and down and down until they just take it off the risk page. So there was a little bit of excitement about either having a very close pass in 2043 or a very remote chance of a hit. But it's not gonna. We're good out for a century. And then, no sooner than that, there were two more that came by, 2014 EF and 2014 EC, which came 40% and 20%. 2014 EC was just above Geosync, as a matter of fact, where it passed about 20% out to the distance to the moon. And our folks at the Virtual Telescope Project, they actually ran a live feed. And I was basically just updating that post all this week as all these asteroids kept getting discovered. There was just more and more information to put in there. One was 15th magnitude, and one was 2014 EC was 13th magnitude. So it wasn't quite bright enough to get me in the backyard looking for it. If they're above 10th magnitude, I kind of get excited, then I'm out looking for it. Kind of neat to see an NEO asteroid when they're going by, because you can see the move in real time in the eyepiece if you can get a good track on them. So it was an interesting week for asteroids, NEO asteroids.
We sure live in the cosmic shooting gallery.
Yes, we do.
Okay, so Brian Coberland, I'm going to give you 1 minute to explain why quasars help explain why we have free will. Or don't have free will.
This experiment has nothing to do with free will. It doesn't. It's called the EPR experiment, or Einstein-Podolsky-Rosen experiment. It is one of the classic experiments of quantum entanglement. It's basically a way particles are quantumly connected. And it's been done in the lab over and over and over again. And basically, as its standard interpretation, is it shows that there isn't any hidden variables, any faster-than-light communication that's between these particles. And they've always been done in the lab. And one of the arguments, kind of, if you're really pushing it, if you really want to be really skeptical, one of the arguments against it is, well, you haven't shown that they weren't entangled before you did the experiment, because it takes time to do the experiment. And so the whole time that you're setting up, the whole thing could be entangled, so the outcome could be predestined, because the whole thing was there. So there was a paper in Physical Review Letters that said, fine, we'll just deal with it this way. We'll have one quasar, billions of light years away one way, trigger one side of the experiment, and one quasar billions of light years away trigger the other side of the experiment, and now we're separated by billions of light years, so it can't have been done beforehand. And it's a way of kind of eliminating all those little philosophical quandaries. It's been proposed before. They've got a kind of an interesting way of doing it that's actually, it sounds practical. It sounds like, you actually could do this. It's one of those things where it's an interesting side note, but it doesn't have anything to do with free will.
Nicely done. You pulled that off.
But it makes great link bait.
It makes
well, yeah. That's the thing. I mean, you're our pitbull.
You see
around.
This was caused by people writing things like that. So yeah.
Well, that's the thing. Brian is our pitbull at Universe Today, and we send him out to debunk the stuff. So yeah.
You know what Matthew said to me on Twitter? He says, "Dude, really?" And I'm like, "What? Come on."
I was hard on Jason. I apologize, Jason. I was hard on you.
No, but that was great because because he's like that's not what Bell's theorem is about.
Yeah.
That's not what it says. And I'm like, well, then what does it say? And then he got to say what it says and all that other stuff. Why? Now, why is that cool? That's cool because there are a lot of people out there like me who kind of read things, especially if they've been put out by if it's a press release or something like that. And if that's been kind of spun up a little bit, well, then we take it for face value that that's really what it means, and then I may spin it a little harder. So, it's important. It's important to get that type of stuff.
And it is friggin' cool. I mean, there's no question that this is not a cool idea, and it is. They go through a lot of trouble in the paper to sketch out exactly how to do it with existing tech.
Yeah.
Which is, that's something that, frankly, speaking as a theorist, many theorists wouldn't bother to do.
Yeah.
So I think it's really, really an awesome idea. So
where you should be
no need to
impressed
hype
with this is this type of experiment was proposed since the experiment was done. Well, fine, just do 1 light years away. These guys actually said, okay, we can do it. This is specifically how you would do it, and it can be done. That's impressive, to be honest.
There you go.
It's one thing to sit around a beer and say, oh yeah, I could do this light years away.
Yeah.
But the details are the trick.
Right. How do you
It is
get the
great.
light from a quasar into your experiment and entangle those
In real
photons?
time.
In
in real time, yeah.
Yeah.
That's the trick.
Yeah.
Yeah.
Making that trick where the Aristocats.
All right. Well, let's wrap this up, guys. So Alan Boyle, where do we find out more?
NBCnews.com/science or cosmiclog.com. And there's a little item about Planet X that I'm hoping to do up a little later this afternoon. So
Now, is that a new
for
Twitter
that.
I'm seeing?
The A boy. Oh no, I mistyped that. I'm glad you mentioned that. I'll
Alright.
fix that. So never mind.
That's got too many letters and not enough numbers in it.
Yeah, it needs at least 1 number. There we go.
You got to turn it off and then back on again.
Okay, very good.
Wait, and
Is it there? B0YLE.
that's how we find Alan Boyle.
Good. There it is.
Although that A Boyle one might, you can change your Twitter
I
name.
should
and
think
it'll-
about that. Yeah.
Yeah, it'll bring everything over to the new handle, and you won't have to explain that that's a 0 every time you talk to people. Just
There you
saying.
You can't.
In fact, you know what? Weekly Space Hangout recommend new Twitter handles to Alan Boyle.
Mm.
If you have one, just send him a tweet at
Yeah, at
B0YLE,
B0YLE.
and he will. And he will. be
And
able
I'll
to
send
send
3D
it.
glasses to the winner. But
there
it
we
has
go.
to be one that's available. So
Right. Yeah. No. It has to be an available one. Yeah. Okay. Great. Brian Coberline, where do we find out more?
You can find me at briancoberline.com. You can find me on Google+, and my Twitter is Brian Coberline. So
And you've been rolling out your website a lot more now, putting a lot more articles on the
I have
website.
been. I've been initially posting there and then posting on Google+ instead of the other way around.
And
So come
how's
and
it-
check it out.
And if you have any interest at all in the electric universe theory, I highly recommend you check out a recent post by Brian.
Oh,
If perhaps you consider
thank
if you consider that perhaps mainstream science has it wrong, and that in fact the electric universe theory is correct, Brian's got a very interesting article I think you're going to want to read.
Oh, thanks for that.
All right, Dave Dickinson, where do we find out more?
Say this week I was active on Universe Today, Astroguys, Listosaur, Canada.com, and I will be Sunday going around and hunting out all the non-network clocked in my house and setting them an hour forward. And I'm also writing up a good post on the occultation of Regulus by asteroid 163 Aragon on March 20th. That's going to be a big event coming up. So
This
that
is going to
will
be big, isn't it? Yeah.
Monday.
It's got to be good.
Yeah.
Jason Major, where do we find out more?
I'm at lightsinthedark.com. I'm on Universe Today, Discovery Space News. I'm on Google+. I'm a moderator at the space community over there. If you haven't joined the space community, please do so. It's a lot of awesome stuff. And I'm on Twitter at JP Major. So a lot of space tweets going out every single day.
Dr. Matthew Francis, now is another chance to plug your course.
Yes, well, we actually have 3 courses coming up. Check out cosmoacademy.org. We have 3 classes coming up within the next month and a half. One is on creating awesome astronomical images from existing data, and that's taught by Peter Dove. We also have astrobiology with our very own noisy astronomer, who isn't with us today, but Nicole Gugliucci is teaching a class on astrobiology. And then I will be teaching a class on gravitational lensing in April.
How cool is this? I mean, I just got to say, how cool is it that we've got all of these PhD astronomers and astrophysicists teaching directly through Hangouts and like an actual curriculum. If you have an interest in, in scientific, creating photographs from data sets, in astrobiology, and it's crazy. This is amazing to me that this stuff is kind of available now. And if you have any interest in this, I mean, the fees are not that high, and it is a chance to go and learn cutting-edge physics and astronomy and astrobiology from researchers that are working in the field. This is an amazing opportunity, and I really think people should go and check it out.
And it's a small class setting, not a MOOC. So you're not one of 500 students. You're one of 8 students, and so any question you have, we can answer in real time. You are not going to be ignored. So definitely join us, cosmoacademy.org. For my writing side of things, check out bowlerhatscience.org and galileospendulum.org. Lots of ORG here.
Now, what do you hang on that tiny little hanger behind you?
That was left from the previous occupant of this apartment, and I just have never moved it. And it's a regular-sized coat hanger.
You just put a bookshelf right underneath it, because
exactly. That was a very useful place to put my books.
Yeah.
Every time he throws it away,
in case anybody doubts my credentials to talk about black holes, you can see that I have the credentials to talk about black holes.
That's great. You are so
I've got that black book too. So.
Okay, great. Well, and I'm Fraser Cain, of course, publisher of Universe Today. We just released a whole bunch more videos, a new run of our videos on YouTube, and I'm sure Brian and Matthew would cringe at the topics, like how do you kill a black hole and why we live in a special time in the universe. But I hope you guys will be happy with my answers. We're also, if you want to go to patreon.com/Universe Today, you can see how you can actually get involved and support the efforts that we're doing with Universe Today. You can have all the advertising removed from Universe Today. I will follow you on Twitter. We'll put your name in the credits for the stuff we're doing. So definitely check that out. And that's sort of the new project that we're working on. So patreon.com/Universe Today. So hey, thanks guys for joining me this week. I really appreciate it. Thanks to all of you for watching. I hope we sort of did all of this news justice this week. And next week we will have all seen Cosmos, and we will join around the virtual water cooler and tear it apart. So, hey, thanks everyone. See you all next week.
Bye.
This afternoon, but we'll see.
I won't let it. I won't let it take that too.
I've got science to talk about too. I've got to talk about science.
I know. It's taken so much, I'm not going to let it. So I apologize. I've got a bit of a cough going on. I will try to mute as I hack and cough. Now, before we get on to the actual show, I just want to do a little bit of housekeeping here. One is that you can always interact with us. We love to hear your comments and questions. So the best way to do that is to use the Q&A app, which I have enabled for this Hangout. You should see that no matter where you're watching this. You should be able to see that Fraser is interacting with the audience, and you can come in and have a conversation with us, ask us some questions, and I will try to insert them into the show. The second thing is the Weekly Space Hangout is going to iTunes. So we know that a lot of people have wanted to get a podcast version, video and audio of the show, and Susie Murph, who's our producer for Universe Today, is going to be helping to bring that over to iTunes. So hopefully in the next couple of days, you'll be able to subscribe on iTunes and just whatever podcatching software you like, and you will have it downloaded onto your portable device, just like Astronomy Cast and other shows like that. So not that we wouldn't love to have you join us live, but I know that a lot of people really like to get the stuff on their portable device. like me. So, so we'll get. That's what we're gonna do. So first, let's start and let's. I gotta know, Alan.
Yeah.
For some reason, the good folks at Cosmos chose you.
Well, no, you know, Neil and me.
I know
we're
you
just
guys
like
are
that.
tight.
Yeah.
Tight.
We're the yin and yang of the Pluto controversy. They just sent out previews of the first episode of Cosmos, the show that made such a splash in 1980 when Carl Sagan brought it to primetime television, and it's coming back to primetime television starting on Sunday with.
There has got to be a faster way to do this than slowly clicking everyone's faces. But maybe people like that. It's like this slow reveal. Like, who's it going to be? All right. Well, hey, everyone. My name is Fraser Cain. I'm the publisher of Universe Today, and this is your weekly space hangout for Friday, March 7th, 2014. We've got big news today. We've got close passive asteroids, asteroids falling apart, gravitational lensing, the NASA budget, and possible evidence for dark matter, quasars. It's going to be cool. And we've got a sneak preview, well, not exactly a sneak preview, of the new Cosmos series. Alan's seen some of it, and he'll be able to talk about it. So, and speaking of Alan, we're joined by Alan Boyle from NBC.
Hey,
Alan?
yeah, I finally figured out how to hook up this Google thing.
And I just want to note your lighting is just, it's perfect. You
The
just
sun is
look
shining in
terrific.
Seattle, so that's what makes it so nice.
That's awesome. Well, it's great to have you back. We got Brian Coberline. Hey, Brian.
Hi, how are you?
Good. We got Casey Dreyer from the Planetary Society. Casey.
Hey, Fraser. Happy to be here.
You are not.
Yes, I am. I just
Okay,
have
good.
Happy news.
Okay, good. All
It's a
right.
mix.
You're happy to be here. You just don't have happy news. All right.
I can
We got
still
Dave
be bold.
Dickinson. Hey, David.
Hey, another wacky week.
It has been a wacky week. Got
always.
Major Jason Major.
Hey, Fraser, I'm trying to get better lighting because I'm jealous of Alan. So.
We all are now.
And we got
Come
Dr.
on
Matthew
down.
Francis, newly returned from Science Online, and I hope you can let us know how that went as well.
If we've got time, yeah, I think NASA budget is probably going to eat up a lot of our brain power.
Such a powerful force in the old and the new Cosmos. If you want to hear what Anne has to say about it, you can see that story as well.
Yeah, we'll put a link to your article in all of the various show notes that we do
Right.
because it was just it was a terrific article, and that's what got my attention. And I nagged you, and then you said, "Oh, I'll jump in and tell you what I thought." So, did you enjoy it?
I did, yeah. It's I guess some people have talked about how Neil comes off in it, and Neil deGrasse Tyson is a little bit better if he's more extemporaneous, you know, if he starts to mix it up a little bit. This is more of a scripted sort of thing. It's very much like the Carl Sagan tone, and I think Neil is probably going to take a while to get comfortable with that tone. He does go back to his own encounter with Carl Sagan when Neil was a 17-year-old student from the Bronx and went up to visit Carl, and it's a nice way to kind of bring the whole thing full circle, that the torch has been passed to a new generation and a new show. So I don't know. I wouldn't make too much of the Neil versus Carl. Some people have compared it to Kirk versus Picard, but I would say just kind of enjoy the spectacle of it, because of course the way that the story is presented with all the tools that are available in the 21st century is really what makes this Cosmos fresh and new.
How is it on the spectacle front? Because we've seen, and many of us are responsible for digging up the same tired animations of black holes and sweeping views of from Cassini and things like that. So did they go back and throw a lot of money into the computer graphics and the stuff you see on screen?
Yeah, they did. I mean, it's hard for us. We're so inured to series. Another thing that's been carried over is the ship of the imagination. This is something where you saw Carl sitting in the driver's seat, and that would take you to all the far-flung frontiers of the cosmos. And there's an upgraded, pimped-out ship of the imagination that Neil deGrasse Tyson is using for his show. So, but the spirit is the same. Like I say, there are some extra twists that have come up since 1980, and we'll be getting into more of that as the 13-episode series progresses on Fox and the National Geographic Channel. You know, about the multiverse, about discoveries in evolutionary biology, and another feature is that they have animated sequences that pay tribute and tell the story of people throughout history who have championed the ideals of scientific discovery. The first one is Giordano Bruno, this friar who, you know, back in the 16th century said that all those stars in the sky must have planets around them, and there may be people like us on these planets. And he was burned at the stake because of his views on that and other subjects. And but it turned out that that new planet thing wasn't such a crazy idea after all. And so that's explained in the context of what the frontiers of our universe look like. And in the future, they'll have more of these animated sequences that kind of bring a new dimension to the show, put scientific discovery in a historical perspective. So that's the sum of what I took away from the show. I did write about it in a preview on NBCnews.com, and so if people want to get more details and want to hear what Ann Druyan, Carl Sagan's widow, who was such a Neil deGrasse Tyson as the host, and so
now I would show a preview of the show, but then this show would be taken offline on YouTube. So I'm not going to do it. And I will.
But you would get billions and billions of hits. So,
billions and billions of copyright takedowns is what I would get. So let's just assume it's going to be a show. It's got pretty pictures. Neil deGrasse Tyson talking.
Yeah. Well, you know, the pretty pictures are not an insignificant thing. That special effects have come a long way since 1980, and so you'll see that reflected in the show. That's one of the big differences. Another difference, there are some of the aspects of the science that have changed. You know, the explosion and extrasolar planets. Actually, the explosion on the rim of our own solar system. All the objects that have been found in the same vicinity as Pluto. And speaking of Pluto, you might know I wrote a book called The Case for Pluto that tries to plead the defense for that poor dwarf planet. There's a tangential reference or two to Pluto, but even if you're a Plutophile and you think that Neil is on the wrong side of the issue, you shouldn't get too upset. It's just a tangential thing, so don't worry about that. This first episode follows the game plan, really, that Carl had for his first episode, laying out the space and time parameters for the whole cosmos. You know, back in 1980, it was thought that the universe was maybe 15 billion years old, but people really didn't know precisely. Now we know a little bit more precisely. It's 13.8 billion years or so. And so that's reflected in the cosmic calendar. This device, it's a cool graphic that shrinks the entire history of the universe down to 1 year and all of recorded history down to 14 seconds on the last day of the year. And so that is something that was carried over from the first